the back having capacity 5. And for capacity 10, I think the best we can do would be we split it to 7 plus 3 or 4 plus 6, giving us 25. I think that's it. So we find out that if we have capacity equals to 10, the highest value we can get would be 25. Now, if we consider the time complexity of this approach, we have, well, let's say the time complexity of this approach, at the very beginning, we have this array containing n elements, where n is the capacity plus 1. And then we also created an array called V, having n plus 1 elements. Then for each of the elements in V, what we did, we considered roughly for each of the elements Vi, we need to consider roughly half of I number of scenarios, including the first one, we're checking if there's an element that takes all the space. Then we will try to do the split, I minus 1 and 1, I minus 2 and 2, and so on, as documented here already. And then roughly half of I number of options we need to consider. And for each of the option, for example, if we are taking this option out, what we need to do, we only need to calculate I minus 2 plus V2. So we only need to take two values out of the array V and add them up together to give us the value of that option. So evaluating each of these options will only take constant time, and evaluating all of them takes half of I amount of time, or we can say it takes OI amount of time. And we will need to repeat this for each of the I, starting from 0 to the capacity n. So I think the overall complexity for this case would be n to the power of 2. We need to fill each of the cell one by one, and filling each of the cell, we will need to consider half of I number of scenarios. So we have n to the power of 2 as the time complexity. And clearly this takes polynomial time rather than exponential time. All right, I think that's it for this question. Next week we'll have another question, a similar question, talking about can we try to find out which item is the most valuable item by taking the value divided by the weight. I think that would be the unit value. So the value per one weight. And if we pick the item based on whether the item is valuable or not, does it help us to solve the knapsack problem? So in the next week's tutorial, we're going to have one question discussing that using greedy approach. We'll see more details next week. So for the last question today about the Warshall algorithm, in this case, we have a graph having 4 nodes only A, B, C, D, and 4 nodes